Okay, so let's go ahead and get started. Good morning, good afternoon, good evening, everyone, for the customers who are joining us from across the globe. Hello, everyone. My name is Lokesh Shara, manager for the Arista Technical Services team, and I would like to welcome each and every one of you to the third webinar hosted by the Arista TAC team. And before we begin, I would like to thank you all for the overwhelming response what we have received in this initiative. This is the first time we are working on such an external initiative from the TAC side. And we kicked this off effort in September 2022, and this is the third session in the series. Our team here has put in a lot of effort to ensure that these sessions are able to provide you with a great insight into the Arista EOS and CloudVision world. So moving on to the slide. Quality support has always been at the center of all the initiatives we drive at the TAC organization levels. Our customers have echoed the same in the recent 2022 NPS survey, where we have received a +80 score, which actually stands for the world-class support. TAC webinar is one of these initiatives where we want to provide an opportunity for the Arista TAC and our end customers to connect outside of this usual problem-solving scenarios. And with these webinar sessions, our aim is to work on knowledge sharing with our customers and cover topics in depth, which are most useful and applicable to all our customers. So for the 2022 series, we actually started with the baseline details and topics. So far, we have covered EOS device health checks in session 1. And building on to that, we covered EOS upgrades scenarios in session 2. So recording of these previous sessions, they are available on the Arista community page. And for this third session here today, we are going to cover a reload and upgrades of the EOS devices that are in Mlag or have multi-supervisors, dual supervisors. So similar to the last two sessions, we are actually going to cover these topics first from the CLI side, and then we are going to take a look at the same from the CloudVision side for the customers who would like to automate things. We'll also have the automation component in the CLI side as well. Today, we have two of our best engineers here who will be taking us through today's session. We have Jonathan Curtis, who will take us through the CLI component, and then we have Grant Bonds, who will run with the CloudVision side of presentation. This session again will be recorded and it'll be made available on the Arista Community Central if you would like to have access to these recordings in the future. Along with the presenters, we also have Arista technical leads as part of the panel who can actually help answer any questions what you may have during the presentation. You can use the Q&A manager to ask our panelists any questions or raise your hand, and we can definitely unmute you and you can ask your question. We'll try our best to get to all the questions in the stipulated time, but in case we are not able to, we'll definitely follow up via the email after the presentation. And if there are any unforced errors during the presentation, we apologize in advance, and we'll be looking out for feedback to make any improvements in our upcoming sessions. So without taking any further time, I would hand it off to Jonathan for taking you through the CLI part. Jonathan, take it away.
Hey, thanks, Loki. So yeah, my name's Jonathan Curtis. John and JK are both also fine. And I'm looking forward to talk to you today about Mlag and multi-supervisor devices and how we handle reloads and upgrades on them. And I think the best place to start here is with an overview of Mlag and the ISSU. So Mlag, or multi-chassis link aggregation, is there to provide us redundancy at L2 so that we can minimize traffic disruption on device failure or on a switch reload. And so in order to do that, it uses these multi-chassis lags, right? So you've got a port channel here connected to this host and a link that goes to switch 1 and switch 2. And these are regular front panel connections. Now you'll see switch 1 and switch 2 also have these inter-device ports. And these are also regular front panel ports. There's no proprietary cable or connection there. It's all handled via the configuration. But these also belong to a lag, and we use this to stream data back and forth between switch 1 and switch 2, so that if switch 1 learns a MAC address on port channel 1, it can tell switch 2 about that MAC address. And so switch 2 knows how to reach that host without ever having to actually receive a packet on its local interface. There are some considerations, however. So first and foremost, anytime you're doing an upgrade or changing, even if it's a downgrade, so anytime you're changing EOS versions, the 2 EOS versions that are running on your individual switches must be compatible. So we have a really easy tool that's located right here at this link, and we do give copies of this slide deck out. I think they're linked on the Community Central page, so this link will be active. You can click on it. And it's right on arista.com. It just tells you, hey, these images are supported to run on 2 devices at the same time. Aside from our EOS versions, we also need to bear in mind that maybe not all of our hosts or connections use a multi-chassis lag. So host 2 in the bottom right does, but host 1 doesn't. So there's nothing that we can do that's going to prevent host 1 from losing connectivity if switch 1 gets rebooted, right? And that's fine. We just have to be aware of those expectations before moving into a maintenance window. And then lastly, Mlag doesn't directly provide any L3 redundancy. It's there for L2 redundancy. So we need to be aware and prepared for how our hosts reaching their default gateway. Where is it configured? Are we running VARP or VRRP on these pair of switches? If not, and maybe the default gateways at the spine, do we have routing towards the spine? Is it ECMP or is it L2? And just all of those little things that, again, we want to be aware of before we go rebooting devices in the network. So the common list of errors to potentially check for are going to be, do we have matching VLANs on the 2 devices, matching switch port configuration, spanning tree, Mlag port channel configuration. And thankfully, we dump all of this into one nice show Mlag config sanity command. Again, this is an active link. It'll take you to the little TOI where it documents everything that you get to see. And we do run through it in the first video demo as well. So this is kind of your one-stop shop to at least cover all of these considerations, make it a little bit easier. Now, once you've reloaded a switch, there is an inherent delay that's built into Mlag devices that prevents them from bringing up all of their front panel interfaces immediately. This delay is it's right here, this reload delay on this platform. It's 900 seconds. It is platform dependent. So it might be 300 seconds, might be 600 seconds. You can use this grep if you want to find it, or you can just look at the output. It's a little bit further down from here. So when you reload, what you're going to see are your front panel connections that are not this inner switch link will all go into an error disabled state. And that's fine. Again, it's expected. These 2 links that connect switch 1 to switch 2 will be the only ones that are up. And if we were rebooting switch 1, let's say, when it comes back online, switch 2 will use those links to stream information to switch 1, so that when it brings all of those interfaces up, it already knows about all the MAC addresses and which ports they live off of. It already has an idea of the spanning tree state. And so that way, it, again, minimizes any disruption to traffic forwarding or flooding. And then some basic upgrade steps. So this won't look really anything crazy. It's kind of a standard, you're upgrading a device. With the added caveat of maybe this first step, we want to check our images. So this is a snip from what that tool on our website looks like. If we're running 422.0F and we're going to 427.0F, they're compatible. Everything's fine. We're going to want to build some health checks into our upgrade steps. And then if you were here in session 2, where we talked extensively about upgrades, we're going to set our boot config. We're going to reload one of the switches. Now, we say here the Mlag secondary. It could be the primary, but we say the secondary here so that we can have like a clearly defined process where everyone's saying the same thing. If you decide to ignore that bit and do the primary, it's fine. After our reload, we're going to do a health check. And that health check isn't good till all of our interfaces are up and forwarding. We don't want them in that error disabled state. We'll start black holing lots of traffic. Then we'll reload our second switch. We'll do our health checks and everything should be great. There is one added step if they are not EOS compatible. So the nice part here is the tool will tell you what versions of EOS are compatible with your current and target version. So you see I changed our current version to 4.17 from the 4.22 before. And these 4 versions of EOS are compatible with both. So we can kind of leapfrog using this interim version, which looks kind of like this. Right, so we have one added reload. So one added step really, or combination of steps if you include the health check, where you're going to go to an intermediary image, then your other device will go to your target, and then your intermediary device will go to your target, right? And then replacement of an Mlag switch. So the best way to do this really is to just get a copy of the configuration and your EOS version, the target EOS version running on the device before we cable anything. Right, so if switch 2 is down or dies, you get an RMA, switch 3 comes in, you preload your config, you get it to the EOS version you want it to be running on, then you connect all of your cables, you turn it up, and everything's fine. Meanwhile, switch 1 was handling all the traffic from the get-go, so you didn't really lose anything. It's just a quick and easy way to cover the replacements. If you want a little bit more detail on all the fun bits and show commands, great Community Central article, right? This link here will walk you through this exact same process, just with all of the additional outputs. And then we're going to jump into a demo. I have this preloaded in another tab here, but what I wanted to call out, because you won't see it during the demo, is this diagram. So there's 2 things here. We'll have this host that's in our bottom left who's pinging his gateway. And you can actually kind of see it's this bottom right tab here. Arista 1 and Arista 2 are my left tab and my top right tab. And this L2 switch here is just there to ingest some problems into my upgrade so that I can demonstrate what that looks like. Let me go ahead and pop that open. All right. So the first thing, I just want to show you the version of code we're currently on, right? This is an upgrade demo. So we're going from 426.3M on the both switches, and we'll upgrade both of them. And we've got pings in the bottom right there from our host to our gateway. The first 2 commands I'm showing here are show Mlag and show Mlag detail. Detail is going to tell me, okay, Arista 1's my secondary, and both of them tell me, okay, there's some sort of inconsistency in our config. And that show Mlag config sanity actually tells me all of the information right here, but I want to actually show it. It's basically saying that there's this interface port channel 100 locally that has that Mlag 100. That's what tells the 2 switches that it's supposed to be a multi-chassis lag, that subconfig. And if I check on Arista 2, there is no port channel 100, right? So this is just a misconfig. That said, if we proceeded despite this misconfig, there's no downside, because as we see on the left, port channel 100 is down, there's no interfaces in it. It's probably just left over from some old config. The second thing I'm showing here is our spanning tree state. Now, thankfully, you don't have to remember this command, but I want to show it to you. It's show spanning tree instance detail. And it says that the agent is not restartable. It says false, right? And so what we see here on the left is if I try and issue a reload right now, we get 2 prompts. The first you will always see. It's going to talk to you about the Mlag ISSU. And the second is that spanning tree STP is not restartable. So there's going to be some issues during our upgrade. Now, for me, I know what's causing our spanning tree issues because I manifested them. That L2 switch that was connected off my Ethernet 5.1, I set it to continuously bounce. And because that's a spanning tree enabled port, every time it bounces, we've got to remove it from MST, add it back into MST, etc. So for the purposes of our demo, I'm going to fix this just by shutting down the port. In your environment, you should probably investigate why that switch port's bouncing or determine how necessary it is, right? So we'll see right away that show spanning tree detail now says it is restart, STP agent is restartable. It's now true. We can verify that on our Arista 1 device as well. So that pop-up that we got from our reload is good and fixed now. So I'm going to set our boot config on the left side to our destination image. That's our 427.4M. And I know that these are 2 compatible images, and I did check the ISSU beforehand. So I'm going to issue my reload command. And we'll see we still get that message. The switch doesn't know, so you'll always see that prompt, and you just want to go ahead and confirm it. So the first thing to demo here is, in the bottom right, pings are still working, right? There's not a single sequence mixed, and we'll verify after it comes up, which we cut to here. There's our 427 4M. We didn't want to wait the 5 minutes for that to come back online, right? We can see our interfaces are in the error disabled state, so it's relatively recent that it came back up. We do have our one interface in port channel 1000. That's our Mlag port channel interface. We can see that here. And so right now, Arista 2 is streaming some information over to Arista 1 because Arista 1 still has 5 minutes left in its default of, looks like 10 minutes, 600 seconds before it comes back online. But we can see that there's MAC addresses, right? So there's a MAC address learned on port channel 1 and port channel 2 that it's learning from Arista 2. And if we look at those port channels, we don't have any front panels that are active in those port channels. We have these peer Ethernet interfaces. And so a peer Ethernet means it's the Mlag peers interface Ethernet, 1.1 or 3.1 respectively. And so Arista 1 will be prepared to forward that traffic when it brings up its interfaces. So I'm going to speed this up. We don't need to wait the 4 minutes for that to finish. Cool, so we've got just a couple of seconds left now. We can still see in the bottom right, pings are still going, everything's fine. And I wanted to leave that going through us seeing the interfaces come up. Right, and so the first thing I'm going to do here is just check our interfaces again. We've got a bunch of not connecteds. I'm going to filter those out to make this a little bit easier to see. Lots of interfaces in the connected state. This switch has completed an upgrade. It looks like it's in working order. And we see on the bottom right, not a single packet lost. Everything's great. That said, we're only halfway through our upgrade process, right? We still have to do Arista 2. So on Arista 2 here, we're gonna go ahead and set our boot config to that same destination image, the 427 4M. And then I'm just gonna do a little bit of tidying, keep things relatively clean and clear. We do want to restart our pings for when we reboot Arista 2. And okay, boot system command took, that's great. Everything else is cleaned up. So we'll set up our new pings and we'll reload Arista 2. And same thing, we're not gonna, well, Arista 2 will get a prompt here. Yeah, we changed our configuration. We shut down that Ethernet 5.1. In this case, I'm fine with it. We'll just save that configuration. And then we can go ahead and proceed with our reload. And I'm just gonna cut to when that comes back up. You'll see the sequence numbers in the bottom right are gonna jump way high. Yeah, we're almost at 400 now. And there we go. Switch rebooted. It's now on 427 4M. We've got that reload delay, right? And so I'm gonna do the same thing here. We don't wanna look at the reload delay, just count down, right? There we go. Let's try that again. Show Mlag detail. There we go. Reload delay is completed. We saw the sequence numbers in the bottom right again jump from like 400 to 800. All the interfaces are up. Everything looks like it's working. And we again verify no packet loss. And that's a really quick and short version of what the Mlag ISSU upgrade process looks like. There we go. All right, so we talked about Mlag. Next thing here are chassis or multi-supervisor units. And so a little bit of background again. So the original redundancy protocol that we used between when we were running multi-supervisor units is RPR, right? And RPR was great for its time. It synced your startup config, but your running state, spanning tree, all of your links, all of those are temporarily brought down when you have a supervisor failover running RPR. So there was plenty of room for improvement, introduce SSO. And this SSO was some years back still. And SSO is great. It does our running config, our startup config. It's got a hot standby state for a much faster failover. Our L2 state's preserved, so no spanning tree reconvergence. Our L3 state's lost, so routing needs to reform. But all things considered, this was a pretty big improvement, with the caveat of both supervisors have to be running the same version of EOS. And so that sort of poses some immediate considerations when you're upgrading these devices. Without Mlag, you're going to have some sort of traffic disruption. There's just no way to avoid that, because even if you are running SSO and you reboot one supervisor, now you're not running SSO anymore. So when you go to reboot the other supervisor, you're going to have some disruption. So it's always going to be your first consideration when you're working with these devices. Is this part of an Mlag? And then from there, you can start to figure out what does your L2 or L3 downtime look like? What's your control plane downtime going to look like? And then if you're replacing a supervisor, it's not like you get this new switch that you can just plug power into. So how do you get an EOS image onto the replacement? How do you get configs onto the new supervisor? So for an upgrade process, the recommendation is your typical pre-checks, right? Be aware of your L2, L3 state, figure out how it's deployed in your network so that you can be aware of what to expect. Make sure there's plenty of space in Flash, both on your primary supervisor and on your standby supervisor. It has its own Flash. Check your configurations to make sure that they're consistent. There's a great command for that that's in a second demo we'll do. And make sure the same extensions are on both supervisors. They're two independent units, so those extensions matter. But aside from that, it's your typical copy your EOS image to your primary supervisor. Your primary can be used to install it onto your standby with an install command that we demo. And then the upgrade process we recommend is to use reload all, which will reboot both supervisors simultaneously. And the reason for that is if you're going to have disruption, no matter what, even if you're trying to do one supervisor than the other, it just makes the most sense to bring everything down at once, bring everything up at once. And if you need that minimize disruption to the network, put these chassis in an Mlag. Replacements are a little quirky. The first step is to make sure that the supervisor we're replacing is not the active. And typically that's already the case. You're probably replacing it because it's not working, but just in case, that's step number one. Step two is we need to get our image and our configs onto a flash drive, a USB drive. And what we'll do is power down our faulty and remove it, connect a console cable to our replacement, and then slot it into our chassis to power it. Then we'll use that console connection to break out of the typical regular boot sequence and into that A boot shell. We'll insert our USB drive and copy our image and our configs onto that replacement soup, and then we can reboot from the A boot shell. The nice part about this is that our primary supervisor's working the whole time, and we're really just messing with the standby as long as we followed number one. And the replacement supervisor will be running the correct version of EOS already. It'll just work nicely with our primary. SSO should come right up. And then what's a process look like for both, right? So we basically just want to combine all of our checks for both chassis and Mlag into one, big process. So we've got our Mlag EOS compatibility. If it's not compatible, we need to use that interim image and do that leapfrog. We've got pre-checks for Mlag and supervisors. We'll use our install command to copy everything from our primary to our standby soup. And it also updates our boot config, which is great. And then we'll upgrade the entire chassis via the reload all, do our post checks, and repeat on the original box. Okay, so enough processes for a moment. A big initiative at Arista, and not just TAC, I mean, even going back to our software team, we really like to reduce the chance that we can't get you an RCA because we don't have the data. And I still think one of the most common things that I see is, hey, we upgraded this device 2 to 3 weeks ago and something changed and we only noticed it today. Can you help us take a look? And sometimes we can. Oftentimes, frankly, we still can, but there are times that we can't because we just don't have logs from what did it look like before. And so it's really hard to make that before and after comparison. So what's something that we can do as individuals to help with that? And I've proposed something along the lines of the support bundles, maybe along with an alias to make things easier. We can collect this data before a maintenance window, after a maintenance window. We can save it to the switch. We can offload it to a server. There's a whole bunch of ways that we can hold on to this data, and now we have it and we can purge it when we need to, and we can always refer back to it, which is great. And then aside from that, we've done a lot of stuff already in EOS that help us with this goal, right? We've got the historic tech supports that use our scheduler. We've got the streaming latency, be it a syslog, SNMP, or if you're running CVP, that's great. We've got console logs, and I love that I can look at the console logs even 2 days after a reboot with show reload console logs. And then we've even got this AAA accounting is persistent through reload starting in 4.29.0. So that means if someone issued the reload command and you just didn't know, now we can go verify that. It's actually going to persist through the reload, which is great. But on to my suggestion for log collection, right? There's a few things that we need to be aware of, particularly with supervisors. Again, supervisors are each their own independent unit, so we need to know which device we're logged into or issuing commands on to know which one we're getting outputs from. And what I have here is an alias that I've written that I am going to demo in an upcoming video that generates a support bundle on our primary supervisor. It generates one on our standby supervisor. It does some modifying of the name for the standbys so that it's a little bit easier to figure out which one's which. And then it copies both of them to a custom directory. I just call it alias bundle logs. You could call it whatever you want. You just replace things accordingly so that I know where it is. And it's a single directory that I can work with, which just makes life easier for finding them and also for cleaning up old files. That said, if support bundles aren't available on your current version of EOS, you can replace these with other show commands. It would work fine. You could also use the log grab script, which was what predated our support bundle command. And I've got a link to it right here. But the big caveat I want to talk about is alias names can be a little bit quirky. When you name an alias, the CLI thinks when you type in that alias name that it's calling up whatever commands you've listed. I go into a little bit more detail in a few slides from now, but just quick heads up, avoiding things like test or exec, very good for your aliases. And I'd recommend don't include CLI commands. Don't name your alias BGP. I give an example on that exact thing in just a little bit. Before I get there, we're still on logs. So automating cleanup of this new directory. I like automating things. I like a one command to get me all my data. I'd love to have to not remember at all to go clean up those files and not have to worry about flash filling up. So our scheduler, right, is used currently to generate tech support files, those historic tech supports, and it dumps them into this directory. We can use that same scheduler with something like this Linux command. So this will find files that are in the directory that we specify that have bundle in the name and have an M time, a time in days of 14 or more. So this gives me 2 weeks, right? If I run this command before and after the maintenance window, and I have this scheduler scheduled to fire off every day, it'll give me 2 weeks before those files are purged, which is great. I mean, and if you want to increase that, increase it to 3 weeks, 30 days, whatever works best, or lower it also works fine. So that way we have a before and after picture of reloads or upgrades and a huge amount of data to debug if we ever need it. And if we don't, it just purges itself. So the full configuration is long. So I did want to put it down here though. This is one whole line that just got wrapped because it's big. And then we have our second demo. So we're going to do a multi-supervisor upgrade, and we're going to go through what this log collection kind of looks like. And that is in this tab at the beginning. All right, so just like before, starting with our show version, we're on 426.3M again. And this is a 7508, so it's an 8-slot chassis. So the first thing I'm going to do here is create that custom directory I was talking about under Mount Flash. And it's because I've already got our alias pre-configured. So I want to make sure that it's available to dump these files into. And once I've created it here, this is the primary supervisor. I need to do the same on our standby supervisor. So session peer supervisor will actually let me just use the backplane connection over to it. You can see here, I'm on the standby now. And we need to do the same thing, drop into bash, and we'll make our directory the alias bundle logs. And then once we've created it, we can exit out, not just of bash, but we can also just exit to get back into our primary supervisor, which is cool. And again, you can see that we're back on that. We lost that S2 standby and the hostname prefix there. All right, so you can see the alias bundle logs directory is in our is in the Flash directory, and we've got both images on Flash. The first thing I wanted to demo here is this show redundancy file replication. Specifically, that it is not going to have any updates when we use this install source to copy our EOS image over. So the file replication redundancy that covers things like your startup config, your zero touch config, but it's not going to change anything from our boot config, right? And that said, once we write memory, we can see that we'll have some last synchronized updates here. And so the big thing is you just want to check that status column, make sure that it's synchronized, see when it's last synchronized. If you need to synchronize your running in startup config, just do that right mem. And then we jump into that soup log. So that's all I typed in, it's running my alias now, right? And there's obviously a whole bunch of stuff here. I'm going to go through a lot of video editing to speed it up, because we've got tech support and quick traces that are going to be generated here on our primary supervisor. It's going to write that to our directory here. And then it's going to start doing the same thing on our standby supervisor, same tech support, same quick trace, and then it's going to rename it and copy it locally again. This should take 10 minutes plus if you're doing this on a live chassis, significantly sped up. So I just wanted to call that out. But we want to verify that our files made it there. So quick check. Yep, there's our standby.zip and our support bundle.zip. They're both timestamped, which is great. So I'm going to reload our chassis, right? First thing is to see if we get any prompts. And so far it looks like we're good. There we go. So we get one for the 7500 E series module. That's a very old line card that's inserted in this chassis. It's just not compatible with EOS here. We have it in the TAC lab in case we ever need to go back and debug it, but for our purposes, we're good to proceed with that reload. There we go. And so just clearing the console post reload, we're on 427.4M, at least on our primary. We should check the standby, make sure that that one went off without a hitch. We'll use that same session peer supervisor, but I can just throw the command here. I don't want to actually, move my console session over, but it'll return the output, this 427.4M. So both supervisors have been upgraded, which is fantastic. From there, we're going to make sure that the device is up and running before we generate our post reload logs. So here I'm just verifying, okay, all the line cards are up, right? Those post reload steps might be more depending on your environment. You might be checking for BGP neighbors to be up, routes, etc. But once we know that we're in a converged state, generate those post maintenance window logs. And again, I just used my alias, it's soup logs. And a lot of video editing again to get us to the point where those logs were dumped successfully. Again, I like to trust but verify. It says successful. I would like to see it. Great. I've got two bundles per device now, both with timestamps. Great. And so our scheduler. Now here, the scheduler has Arista instead of bundle. I realized this after the fact. I named my device as Arista. This works for me. I'd recommend using the scheduler that I put on the slide deck, which has bundle, which will be universal to any deployment. But that scheduler will automatically clean up our files 14 days from, well, when I did that reload, which was sometime last week. And that's demo 2. So we do have just a couple of common things that I want to run through, especially since I called out that we'd be talking about them. Alias names matter. So in our first bit here, I have an alias named BGP that does a show IP BGP summary. If I'm trying to configure something under router BGP and I type in BGP ? This information is what you'd get if you put show IP BGP summary ? Whereas if you're trying to configure something, you'd have all of these other options. So bear that in mind when we're naming our aliases. Just make it a little bit unique so that we don't run into quirky little things like this. And then a second bit we wanted to talk about, right? Spanning tree not restartable. I did demo this in the first video. And it's that top scenario here where we had this L2 switch. So if you've got a switch port that's running spanning tree and it's bouncing, it's going to put you in that not restartable state. And I have this listed as an L2 switch here. It could be a host, right? If you don't turn off spanning tree facing the host, it'll still have the same effect. A second common one is if we end up in a backup discarding state. If you're not familiar with backup discarding, it only happens when we get a BPDU that the local switch sent, which means there has to be a loop somewhere. So if you had like some L1 devices down here, and we send something out 5.1 and it not hairpinned, but looped back and came in on 6.1, Arista 2 would put 6.1 in a backup discarding state, and spanning tree will always report not restartable when we have that state active. So those are the two big, probably most common things that we get when someone's trying to do an upgrade and they get into this not restartable state. And then lastly, if SSO is not ready for failover. So first, this may be normal and expected. So my first question would just be, how recently was it reloaded or upgraded? It can take quite a bit of time for all of the agents to be in perfect sync and for redundancy to be available. So I'd say give it half an hour, and that might even, it's going to be chassis dependent. The bigger the chassis, the longer I would expect it's going to take. Also, it's going to be configuration dependent. The more features we have active, the longer it's going to take for failover to be ready. So just bear that in mind. The second bit, if you notice that it just never comes up and you're running very new hardware, like brand new line cards that we just released last month, there's a good chance it's not supported yet. So when we first release new hardware, it typically only supports RPR. That SSO will become available as we continue to develop it. And you'll definitely get a log message. So you can just do show log system pipe grep for SSO, assuming that you caught this somewhat quickly during the switch's lifetime. If you don't have logs from when it was last reloaded and it was reloaded a month ago, then it might be harder to find the log. In which case I'd say just open up a TAC case and we can check, or your account team can probably check too. But that's it for me. I hope between the two demos, you learned something useful today. I'm going to hand things over to my colleague, Grant, who's going to talk to you about some of these same concepts, but from the perspective of CVP.
All right, thank you very much, Jonathan. My name is Grant, or I should say Bonds, Grant Bonds, as the slide states. And I'm here today to talk to you about our Arista CVP Mlag upgrades. Pretty straightforward to the point, so let's get started. The first thing you should know is for the Mlag ISSU upgrades that we're talking about, the primary method we have in CVP to actually perform that is our standard change controls. And on top of those change controls, there's really just one thing we're going to edit. So if you look at the right, we can see this is a pretty standard change control window. You got your root stage, and then we have our Mlag upgrade with 6 actions. In this change control, we're upgrading 2 different switches, and we can see in those upgrade image tasks, they've been surrounded by a check Mlag health task. And so this is our methodology in CVP, how we like to make sure Mlag is okay before we move forward with each stage of the upgrade. We have a couple requirements. So the first thing is the ISSU upgrade must be done in series for each Mlag pair. You'll notice everything on the left side is blue, indicating that we are in series for every single one of these tasks, even they are broken down into stages. In addition, each switch needs to be wrapped with a pre and post Mlag health check. That's to say that you have that image upgrade in the center there. It needs to have a pre-Mlag health check to make sure that Mlag is up and okay before we start the image upgrade. And then we need to have an Mlag health check after the switch to make sure that Mlag comes back up properly after the upgrade. You can see we have that for both switches. Really, we're just checking Mlag on both sides of the aisle to make sure that we don't have any issues there before we upgrade for the second switch as well. And third, for our change control to succeed in this case, since we have one serial path, all the checks and upgrades must succeed. Otherwise, the change control will halt. It'll let you fix any issues. It'll wait, and it won't go through with those upgrades past the point of failure. So getting into the Mlag health check action, it's a pretty simple action, but it's very comprehensive. Effectively, this action runs 3 eAPI commands to test Mlag. The first one it does is show Mlag detail. It's checking for Mlag to be active. It wants to make sure our port error disabled is false, and it's also looking for that Mlag negotiation status is connected. If any of these 3 are not true, this part will fail out, and we'll keep attempting up to that timeout I'll talk about a little later. The second command is to show Mlag config sanity. Here we're looking for no inconsistent configs on the same EOS version, making sure that we don't have any differences in Mlag. If there are differences, once again, we'll fail out and let you fix that. And the third part is our show Mlag ISSU warnings. Effectively, we're just verifying there are no warnings beside our boilerplate image compatibility warning. So I talked a little bit about the timings of this health check action. Effectively, we have 3 scenarios in which this action takes into account. The first one, if we're looking at the device uptime is greater than 10 minutes, we're going to set our action timeout to 10 minutes. So effectively, if we hit an issue or one of our show commands is returning an error, you have 10 minutes to fix that before the action times out, and it says, all right, we're gonna let you fix it offline outside of the change control. In addition, if you have a reload delay, so if you've reloaded Mlag recently, the action timeout is extended by that reload delay, so you still have 10 minutes to make sure that Mlag is okay. Finally, if our device uptime is less than 10 minutes and there is no reload delay, we just set our action timeout to a default of 30 minutes. All right, and so instead of doing everything manually, we can actually leverage templates as well. These templates help to reduce manual operations and increase the level of automation inside CVP. The change control templates are very flexible, they're repeatable, and they're made of action bundles. So if this isn't very familiar, go back to webinar 2. We have a great overview of exactly how to use templates and change controls in that way, specifically how to create them. So in this case, if you are familiar with the pretty standard action bundle dialog, you'll see that the action bundle is very, very simple here. Effectively, we're going to create a check Mlag health task. We're going to match on our task device. We're going to add in our provisioning execute task. So that's whatever task is assigned to that action. In this case, it's going to be an image upgrade. And then we have our check Mlag health action at the end, wrapping up our action bundle. Note, you will need to select series in the action bundle, so make sure that is selected to ensure that we maintain those requirements that we had in the first couple slides. And then once you have that action bundle, it's very simple. We can create our template with the action bundle. My case is named full Mlag action. We're going to filter for all devices in the change control. So effectively, we can apply this across every device automatically, and we'll arrange those bundles in series, once again, to stay in compliance with our previous rules. And effectively, once you've done that, you'll have an output of the exact same thing we saw on the first slide, just automatically whenever you push in your image upgrade tasks. And we can verify that, one, we have both our devices being upgraded here. You can see the CZ303 and 302, and each upgrade action is wrapped with a Mlag health check action, as well as everything being in series. All right, so before we move on, we have a couple Q&As. If the Mlag health check finds faults, so you can see here, this is a CVP log message, and effectively it's saying, hey, we've checked Mlag config sanity, something's not right. What do we do? So you can see that we're going to check it every 30 seconds, and we can see the number of attempts as well. However, if the error is resolved before we have that timeout, so it's either that 10 plus timeout or 30-minute timeout, we'll just move on to the next command. So the Mlag health check action is pretty smart in that regard, in which if it's just a minor config thing, you can absolutely tweak it and we can keep moving. However, if the runtime does go beyond the timeout, the health check action will say, hey, there's an issue we couldn't fix. Take a look at the actual CVP or the switches CLI to make sure that you have everything okay on Mlag there. All right. So what happens if we have an innocuous error? And in this case, by innocuous error, I mean something like a port channel that's on one device, but is configured to use Mlag. So this technically is a misconfig. So the proper way to do this would be just to remove Mlag off that port channel. But we have certain situations we've seen in the past where it is difficult if you're in a change freeze or if you're in a very, very difficult change window that we really don't want to edit any configs on the switch. However, we can still do an Mlag ISSU upgrade with some checks. So that original check might be a little too aggressive. So in this specific scenario, we have a custom action bundle that can be applied primarily as a workaround to the initial workflow. This is where our lightweight check Mlag health action pack comes into play. Effectively, an action pack is just a bundled custom action that can be unloaded and unpacked to provide features that's not already in CloudVision. If you haven't used them before, check them out at the source below. This link has our public GitHub page. You can read through the Mlag health check action pack, what it does, and most importantly, how to set it up. I will note that this Mlag action pack is a workaround to sidestep the more comprehensive Mlag checklist while still allowing Mlag to time out and move all those ports from error disabled into normal forwarding. So this is just a quick note from the author of the lightweight check Mlag health action pack. And effectively it says sometimes the Mlag check is a little too clever. We're too comprehensive. So if you want to be a little less comprehensive in this case, you can use this action very similarly as we've seen to the previous action. And this Mlag check will simply check whether there's a reload delay. When the reload delay expires, we'll say, we're good to go, keep moving forward on those upgrades. For implementation questions and issues, definitely reach out to your SE team. This won't be a overarching use. This is very much a workaround, but it's a very effective workaround that we've seen deployed in specific scenarios that you should be aware of when you're doing Mlag ISSU upgrades through CVP. All right, so we have a quick demo here, and this demo will cover the manual version of how to set up everything from a change control and task perspective. So let's go ahead and get started. All right, so we can see we have our Arista 1 container. We're effectively going to go in here, do a manage image bundle, and we're going to assign a new image bundle onto that container. So currently we have the 426.6 that I'm running, and we're going to upgrade to 426.7. Just for instance, these two switches are in Mlag, so they will be used together. That's why we're doing our Mlag ISSU upgrade. So we'll hit save, and we can see that we've generated 2 tasks on CloudVision. When we go into these tasks, we can see our standard change control window. We'll go ahead and select both of those tasks and create a change control. And this part's important as well. Make sure the assignment is set to the default series, and then we'll go ahead and create our change control. We're automatically moved over to this change control window. We can see that both of these tasks have been assigned. So let's go ahead and add in the Mlag actions. So we'll click on a specific instance or a specific task, and we'll go to the Add Actions dialog. Just to make life a little easier, we're going to use the position before and after action. This will automatically insert whatever we want before and after our selected action. So you can see below, we hit that checkbox or that drop-down box, and we select our check Mlag built-in action. From that, you can see it creates a container for a check Mlag health action before and a check Mlag health action after. We'll effectively do the exact same thing for the other switch, adding it to our change control, and this setup should look very familiar as it's the exact setup we saw in our slides. Once again, we'll go ahead and review. Always a good idea when you're reviewing, make sure that the changes make sense. Once we have, go ahead, approve and execute. And so now you'll notice the Mlag health check action completes pretty quickly. It only takes about 5 or 10 seconds to run through, and now we're good. Effectively, all those eAPI commands have succeeded and are ready to go. Now to this part, we're going to speed it up because 2 image upgrades does take about 20 minutes. Right now, we're on about 1,000% speed, but through the magic of video editing, effectively, we're just going to wipe the screen and see what the output of this should be. Assuming all the Mlag health checks succeed and everything is okay there, both switches will be upgraded in standard Mlag ISSU procedure, and we'll get this great output of all green check marks, good to go, and the change control will be completed. All right. We'll let Google roll through here. All right. So for our chassis upgrades, just a very brief slide on the CVP side of things. The CVP config and image pushes will automatically perform a dual supervisor check. So you can see this is a log I pulled off of a chassis upgrade. Effectively, we're going to run a show module. And if there's an error, we'll return, hey, there's an error, so we're not modular. If it's no error, we'll say, cool, we are modular. Let's make sure that we perform the proper precautions when upgrading a device with dual soups. In addition, CVP will automatically use the recommended method of upgrading both supervisors at a time when we're pushing that new EOS version. So just to be aware, if you are upgrading with the dual soups on CVP, that's what CVP is trying to do. There are very few reasons not to upgrade both at the same time, but just to be aware of that standard behavior. All right, this is just a material link for our Mlag ISSU upgrades. The BGP maintenance mode and change control actions are detailed a little bit more technically here, in addition to adding a BGP maintenance mode that we will discuss in future slides for the CVP side of things. All right, and with that, I will turn it back to Lokesh and we'll open up the floor for the questions. Lokesh, it's your mic.
Awesome, perfect. Thank you, Grant. Thank you, Jonathan, for the deep dive and covering these topics in detail. Really great technical stuff here. And we really hope these sessions were helpful for everyone who joined us today. Grant, could you move on to the next slide, please? Okay, perfect. So the recording for these sessions will be available on the Arista community pages as we have the recording for the initial 2 sessions. And we'll also put the slide deck for the reference along with the questions, what we had today along with that. So with this 3rd session, we are going to wrap up our 2022 series, and we will take a gap in December as the holiday season kicks in. But as promised, I think we sent out the feedback form to all our customers who joined session 1, session 2, and we received really amazing feedback. Everyone really liked the initiative, what we are working on. And as promised, as per the feedback, we are actually taking this effort a step further in 2023, where we are going to do a deep dive into the data center technologies, troubleshooting, like Layer 2, BGP, VXLAN, EVPN, and many more. So a flyer for the 2023 series will be out soon, along with the details and the registrations link. We'll send it out to all the customers who have joined us, and we'll also post it on the social media. Also, we'll be sending out a short feedback form for with just 2 or 3 questions for the customers who joined us today. So please take some time to provide us the feedback, as we definitely intend to use it for our upcoming sessions. At this point, going to leave the webinar open now for any questions you may have, and you can use our Q&A manager to ask our panelists any questions. You can raise your hand and we can unmute you as well. So yeah, I'm going to leave the webinar open at this point for any questions. JK, I think Jonathan, you're there?
Yep, I'm here.
Okay, so I think there was one question in between. Let me just from Balraj. I think during one of your demos, you had one interface which was set to flap. I think Sean has answered this question, but like, do you want to provide some clarification on that? How did you set it up to flap?
Yeah, sure.
I think Sean, yeah, please, yeah.
So yeah, it was a fun little problem at first, but if you were here for session 1, one of the things that we talked about is that because EOS runs on top of Linux, and I'm like directly on top of, you can call Linux functions by prepending with bash. But we also showed that if you're in bash and you wanted to run a CLI command, you can call the CLI agent or process and feed it a string, and it'll push the question through like the EOS CLI pipeline. So it's called fast CLI, and we did throw the full example into the Q&A, so I'll have it posted when all this goes. We effectively used that Linux fast CLI option with a for loop to just basically issue a shut and no shut with a 5-second sleep between each. And we just ran it. I think I ran it like 1,000 times to make sure I had plenty of time. So I didn't have to keep activating it or deactivating it. But that's how we were, manifesting the port flapping between 2 Arista devices. Was we used that for loop on one of them.
Awesome, perfect. Thank you, Jonathan. And I think, Grant, there was a question, in case of any unexpected event during the upgrades of a device, is it possible to apply a downgrade from CVP, and what would that procedure be like?
Yeah, so the first thing we want to definitely look at is the why it failed, what happened there, to really get a good idea of how we can prevent it in the future and make sure that we're applying the proper rollbacks. But CVP does have a rollback action. The rollback is specifically for any action in a terminal state of succeeded or failed. So if your image upgrade doesn't go as you planned, or you want to go back in that same change control, you could always roll back that single change. That being said, you can also just reapply a different EOS version. So let's say you were on EOS version X, wanted to upgrade to Y, but realized, nah, we must stay on X. You can always push EOS back through CVP, and that'll work perfectly fine as well.
Awesome, perfect, cool. And I think do we have, yeah, I think we have a couple of other open questions. I think Benjamin, I think he raised his hand. Is there any difference between fast CLI and CLI? So do we have anyone who's willing to take that question? Jonathan, are you open to take that question?
I know Sean's typing it out right now, and
he's
been here longer than I have, but I'll give a stab at what I recall. From what I remember, it changed at some point with improvements. Like, it originally was, I want to say CLI, and then it became fast CLI later as we improved how we implemented building a CLI on top of Linux.
Awesome.
Yep,
but
I think yep, sorry. So just to build on that, both fast CLI and CLI are available on EOS. So the major difference between fast CLI is actually the naming itself. Fast CLI is kind of a lightweight version of invoking the CLI from the bash shell. So it's kind of, it does not load it does not load the full libraries and plugins. You just have a quick connection to CLI, as compared to CLI loads the entire plugins. It's mostly for debugging purposes. So in case if you're writing scripts or daemons which are supposed to run from bash, you can leverage fast CLI. It'll be much more quicker.
And if anyone ever wondered if we're still learning things in TAC, the answer that you just learned today is yes. Yes, we are. Thanks, Himanshu.
Awesome, perfect. Thank you, Himanshu, for adding that. And I think there was another question related to Mlag. Is the 900 seconds Mlag reload delay configured to can we configure this to a lower time? Most certainly we can do that. This timer, as I think Jonathan mentioned during the presentation, is it depends on the platform what you are running. For a fully loaded chassis, this timer is generally longer compared to if you're running like a 1RU or 2RU chassis. So you do have an option to change it, but what comes with the code is the default what we offer at this point, but you can most certainly change it. And What do we have? I think there's another question. What happens to the end device when the Mlag links are down? So I think Sean is actually typing an answer to this, but not sure if you're actually referring to the links in between the devices, which is used for the Mlag control plane. But if you're talking about the dual links or the dual connections, which is going to the end device, we recommend, if you have the underlying devices, the layer 2 devices just connected to the Mlag devices, we always recommend dual connections, so that if one link goes down, the traffic can flow through the other link, which is going through the other peer, and there's always the active forwarding from the Mlag side. So even if one connection is up, you can always have the traffic flow through, and the host won't lose any connectivity at this point. Oh, Mlag links between the switches. Okay, so that even in that scenario, we actually recommend using a redundancy. Like, I mean, as I think Jonathan, when he put out the diagram there were 2 links, but we actually recommend not just having one link, multi-links in that, so, like a 4-channel, so that the control plane traffic works perfectly fine. But I think if those links were to go down for any reason, I think we have like those the MLAGs actually go into like the active forwarding or like a split brain scenario, and we do have come out like active or the scenarios can work in that fashion, but you can actually have, like right now there's a provision which came out in the US code which allows the MLAGs to disable one of these devices so that there's no split brain scenarios take over and any problems which come due to that. Anything else we want to add to that from the tech lead side? Okay.
To Jason's question there, so Jason asked, VMware is proposing to do away with LACP dynamic and instead do dynamic mode links on VM hosts and let them do load balancing instead of the switches. Well, I read the question. I thought I understood the question, and now I'm not sure. Are they, does anyone know, or Jason, do you know if they're talking about moving from like LACP dynamic to like routed links with ECMP? I've seen some other vendors that kind of prefer that method, because that way you can leverage not only ECMP, but also BFD. I can't see that really having any negative impact from our perspective. It just means that instead of doing, if I understand the question correctly, and if not, I can see Apostle is typing your question too. But if I understand it correctly, we wouldn't be using Mlag for redundancy at that point. We'd just be using ECMP anyways, which is already available. So I don't foresee any problems. And I'm curious what Apostle writes out.
Okay.
I have the same question. Just wanted to confirm, essentially, do we have, instead of the lags, are we going to have the VMs connected at least dual linked to the Arista switches? In that case, it should be fine, as long as there is a backup link.
Okay. And I think there's another question from Ben, is that I vaguely remember Arista saying that there's a reserved OUI to use for the MAC addresses to be shared between Mlag members and WARP. Is there any reason to use a MAC address with that reserved OUI rather than just randomly generating with the local bits set? Anyone want to take that question? But
yeah, I'm trying to think. So that's a VARP specific.
Right. Yeah, I think like that is definitely something which we can follow up with, on that. I think we can definitely post the answers to this question when we post out the Q&A on the webinar page. But good question, Ben.
Yeah, I'd say I definitely would want to go refamiliarize myself with how that works and then think of pros and cons to using the randomly generated with local bit versus a pseudo pre-generated. Generally speaking, there's a good reason. It's just I don't know what that is off the top of my head. So look for that one in what we send out in response. It's a really good question, Ben. or Benjamin if you prefer. Sorry.
Cool, perfect. And I think Steve is actually wanted to discuss some Mlag config sanity errors, what he's receiving on the Mlag configuration inconsistencies. So I think Steve, we preferably take that, like I think take that question over like a TAC case. If you could please reach out to support@arista.com. I think like, I mean, we can definitely get sort of like, started with understanding what that is and get you back with a root cause, like why you're seeing those particular, errors or inconsistencies. Okay, and I think there's another one. How can we get the CloudVision trial for performing tests in the lab environment? I think preferably reaching out to the Arista sales team. If you are not aware about like who the Arista account managers or the sales team is for you, I think Scotty, we can definitely check that up, and we can definitely have someone from the Arista side reach out to you to get that set up. Okay, I think if that's pretty much it, then we will wrap it up. If there are any remaining questions, we'll try to reach out to the customers directly over the email. And as I said, like, I mean, we'll try to get more information and provide you whatever details you need related to those questions. Cool, perfect. Then we'll wrap it up for today. Thank you, everyone. Thank you, everyone, for your time and for joining us today. Hope this session was really helpful for you and really great discussion on the Q&A as well. Okay, thank you, everyone, and happy holidays.